Covalent bond usually involve bond that share electron pair between atoms, and we can classify this bond into two. So either the bond is nonpolar or the bond is polar. Let's take a look at nonpolar bond first. So nonpolar bond is the bond formed when the atom has the same electronegativity bonded together. Okay, so for example, Cl bonded to Cl. They have exactly the same electronegativity. So this bond we call it as nonpolar bond, and the resulting molecule we call it as nonpolar molecule. Okay, so if involving only two atoms, we can just directly make conclusion if nonpolar bond means nonpolar molecule. Okay, so nonpolar molecules are covalent between atoms of the same element. So since they have no difference in electronegativity, so they are nonpolar molecule. Okay, so this is the example. What about polar bond? Polar bond is the bond between atoms of different electronegativity. So the distribution of density of electron will be not symmetry. Okay, and we represent the distribution of electron using what you call as the vector quantity. Sometimes you call it as dipole moment. Okay, so the cross end will end up at the more positive atom. The arrow end will end up at the more negative atom. Okay, so if you see the cross, it looks like the positive sign. So in polar molecule contain polar covalent bond. So it has non-zero dipole moment. So mu not equal to 0. So mu we will see later. So dipole molecule in which the positive and negative dipole can be distinguished because of the separation. Okay, so this is example of atom HF. So if you have only two atoms connected, so meaning that you can have only one bond. So directly you can conclude whether the molecule is polar or non-polar because it contains only two atoms. So if the atom has difference in electronegativity, meaning that one side hold more positive, one side will hold more negative, so we represent like this. Automatically the molecule we call as polar molecule. So only two atoms, so only one bond. Okay, so this is mu or dipole moment. So mu or dipole moment is quantitative measure of molecular polarity. So that is the formula, mathematically formula. So when you have dipole moment mu and it has magnitude or direction and it is not cancelled, it is polar. So resultant or net dipole moment. When you want to count the resultant or net dipole moment, you need to consider the molecular shape first. Okay, molecular shape first, because some shape the resultant moment will cancel each other. What I mean by cancel each other? So moment up cancel moment down, moment left cancel moment right. So when it cancel each other, that's what we call as zero. Okay, so if they cancel, that is zero. If they did not cancel, it means it's not zero. Okay, so the bond polarity and molecular shape will take part in this resultant net dipole moment. So in physics, we have a bit same term. We call it as resultant forces. So resultant forces when you want to count forces. So this is quite similar theory, but involving molecule. So if the molecule has resultant dipole moment, so meaning that the moment is not equal to 0, that is polar molecule. But if the resultant dipole moment equal to 0, that is non-polar molecule. Okay, so this is example of non-polar molecule where fluorine and bromine, and they are in trigonal planar shape. So trigonal planar shape is the basic shape, so they can cancel each other, so mu will be equal to 0. In ammonia is not basic shape, it is trigonal pyramidal, so mu not equal to 0, it will become polar molecule. Okay, so this is what I said just now. So resultant dipole moment. So remember, this is lone pair, and lone pair don't have dipole moment. Okay, so the green one is resultant. So hydrogen and nitrogen is more negative, hydrogen is more positive, so all of the moment will go towards nitrogen, and the resultant moment will go towards upward. Okay, so this one we can conclude that nitrogen did not cancel any of the dipole moment, so it is polar. What about NF? Same thing, nitrogen is more positive than fluorine, so the flow of electron going towards fluorine, and the resultant forces will go outside from the nitrogen. This is resultant moment, so it is still a polar molecule. Okay, so characteristic of polar and nonpolar. If you have polar, mu not equal to 0. If you have nonpolar, mu equal to 0. Okay, so we can conclude bond not cancel each other for polar. Usually has lone pair, but sometimes even though it has lone pair, can be included into nonpolar. So this point is not quite favorable. Okay, so this one usually it will come with asymmetrical molecule, so meaning that the molecule is not symmetric, so it's not from the 5 basic shape. Okay, nonpolar, usually the bond will cancel each other. So this is the point that you have to mention in your answer. The bond, dipole, cancel each other, mu equal to 0, and the shape is symmetrical. So molecular geometry is symmetrical. Either they are coming from the 5 basic shape. Okay, so lone pair, I do not advise this point in your answer. Okay, I do not advise this one.